Hello, my name is Alvin, and it's a beautiful another day, so you probably be expecting another beautiful video, right? Okay, we are going to start this video with a problem. The problem is that a bank offers you a compound interest of I, the square root of -1. And if you don't know what that means, then you should definitely check out the AOPS series. And I'll give you exactly 1 minute to do that. And the 1 minute starts in right now. 1 minute timer. You know my 1 minute timer cool tool, right? I just press 1 and then I'll pop the 1 minute timer. I can share it with you so you can see how much time is remaining. So this is how much time is remaining. And there comes a little rubber ducky. It's half the time now. Just pause this video and check out the book and read a little bit from it so you know what I'm talking about. And there comes my cool multiplication chart, right? Cool multiplication chart. Okay, time's up. Okay, now that you've done that, I'll give you 3 seconds to think about the problem. Or actually, done. So now you should have thought of the problem, and on the complex plane, I drew a picture of what it looks like after 32 years and the entire connection, but I'll give you 2 minutes to do it yourself. Just do it on that mode if you have it. And if you haven't, then pause the video and log in into it. There comes a little rubber ducky. The water can also show you how much percent of the remaining time do you have. I'm still waiting. And there comes the little rubber ducky again. What? Or just jump ahead. $32, $31, $30. And there comes a little rubber ducky again. Well, that's probably the last time the little rubber ducky will come. Because the next time the water is so low that we won't see her. Time's almost up. 9, 8, 7, 6, 5, 4, 3, 2, 1. So, okay. Now that you've drawn the graph, I could share the graph with you. Let's see. So it's just over Here, our good friend Desmond. And I labeled imaginary money and real money. This is what happens if you go back in time. Zoom out, no problem. Zoom, 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 zoom. And I can't just go like that forever, so I stopped on the 32nd year, even though you probably earned much more money then. Now we continue zooming in, and this is what happens if you go backward in time. But you know that banks don't like fractions, right? So banks just round to the nearest cent. So you won't get anything if you go back 32 years. So let's take a closer look at this adventure. You start off feeling happy that you have $1. And then a year later, you also have one imaginary dollar. And then a year later, the bank says, your money has doubled. And you said, yay. And the bank says, but now it's all imaginary now. Good for your game of Monopoly, not good for your real life. But it gets even worse. As we continue zooming out, you still keep the imaginary money, but now you owe the bank $2. But it gets even worse. Then you don't have any imaginary dollars and you owe the bank $4. But then it gets even more worse. You owe the bank $4 and 4 imaginary dollars. It gets better though. Then you only owe the bank 8 imaginary dollars. Then it gets better. You get $8, but you also owe the bank 8 imaginary dollars. And then finally, when you waited 8 whole years, your money multiplies by 16. Actually, today there's going to be a long journey here. We'll start off with problems like that, but then that will lead us to talking about imaginary bases, and then that will lead us to talking about what happens if you skip over years of compounding. It often happens when someone gets too bored and then it just doesn't check the bank for a longer time. Good. So now that you've seen the graph, it's time to invest it. Hey, what went on with my deadline? Anyway, I'm going to make a new tape. So wait at what happens when you actually skip over time. So wait. And there it is. Now time to make the tape. Point and also line. So we just start off as normal, having 1 and 0. And then 0 and 2. Good. So let's see what happens next. And there's always a 0 if you skip. And the 0 alternates between directions. And then it gets even worse. And then the 0 alternates directions again. And then again. So that's what will happen if you got very bored and you just decided to skip over some time before checking it in the bank again. You actually get a much rougher crystal. If you call that a crystal because it grows so fast. Then the next connection is over there. And then the next one is over here. And then the next one is over here. Pretty mysterious, right? And then the last connection after all those years of waiting is finally over here. The 0 alternates directions again, and you end up having this much money. But you think that's very much because you know what's gonna happen next. You owe the bank money. And then you owe the bank imaginary money instead. And then it finally comes that the good thing happened. The line gets over here. Now you can guess that this roughly the same thing happens the following years. You only get more and more money and owe more and more money. Over here you owe $1,684. Oh, there's always a 0 there, and that's what is so boring because you never actually get something. Yes, and finally the last connection over here. So this is what will happen if you got very bored and decided to skip over times. Now that's very squarey, right? Or is it not very squarey? Then watch what happens when we go on. Skip 3 instead. Skip 3. If you get even more bored, you might end up skipping 3. A blank wrap, and now we add on this. This time you want to skip 3 because you're so bored. And the third one shows you the time duration. Very handy for if you want to know how much you'd have over a certain number of years, but not so handy for graphing. Actually, if you make a compound more often, then you actually get something more like a growing thin wave. Yes, so that's actually what you get. Save it. For example, this is what happens if you compound every half year. Like this. It actually looks much more like a thin wave than what you get with a rougher version. Over here, we still have the same thing, 0, 2, 0, 2. Well, you start off with 0, 1. Then well, so that's actually 0. Well, there's not always a 0, right? Because this time it is, let's see, 1, 0, and then you get very bored, so you decide to make this -2. So that's -8 and 0. The 0 alternates direction if there is any. Like this. Well, it doesn't actually look like a crystal, right? But over here, that's 16, 16. And this time there is a 0. But the 0 always travels. So this is what it ends up looking like. So this time the 0 is here. That's a silly thought. The 0 actually, there's no 0 this time. Or is there any 0? You can take a closer look at this. The answer is the next time you'll actually owe the bank -64. And then after another year, there isn't zeros anymore, but you get 128. 8 and minus 128. That connects to that point over here. Then another year, this gets to 512. The 0 alternates again. 512, 0. Looks much more like a superstar, right? Doesn't it? 1024. That connection over here. Both of them are -1024. And -1024. Good. It connects to that point there. Now we connect again, but this time there's a 0. And over here we make it 4096. 0 here. Good. It actually looks more like a lightning bolt, right? Doesn't it? -8192. And this one over here is the 8192. Or shall we swap signs? Minus. Good. So now you could probably guess what happens as we continue zooming out. We'll just get more and more money. We let this be -16384, with that one being 0. That's actually not quite it. 768. Good. And then the money gets too big to connect. But if you were to connect it, then you get over to that point over there. Now what happens as we take this away? So that's where the last point ends up being, but we would like the fox to it looks very triangle-y. And it actually looks like if you're toppling over, if you just click default zoom after. It's just like a bunch of random points because because you don't connect by a power of 2. And it certainly looks like you're tumbling over, right? You are very bored today. So you will like to skip after 4 years because of all the fun. Good. So now you're skipping 4. 0, 0, 1, 0, 0. And this is a 1. Actually, this time we should make it this color and also include the lines. It's better not to include a triangle shape, but to include this. Actually gets very boring if you just skip 4. Then it gets to 0. 0. Actually kidding. -4. And then it just tumbles over again to 16. 0. And then tumbles again to -64. 0. You never actually get any imaginary money if you're so bored by then. You just keep tumbling over both sides. It actually isn't very interesting this way. 1024 comes next with a 0. And then another 0 as your money approaches countless. And then another 0 as you have more money than anyone else has in the world. And more money than anyone else owes in the world. Actually isn't very interesting. I don't like skipping 4. It is way too boring. So you elect to skip 5 instead. No problem. But then things are much worse the second year. 0, 1, 1. That corresponds to the opposite point. So, and then after 5 years, you get too bored, so you just decide to go then 6 years, 7 years, 8 years, 9 years, and after another 10 years, your money has exploded. The money bursts over here, a lot like a superstar as we saw in the 3 example, right? Well, and then it bursts off the 128, 8, and one of them is negative. So it connects to this point over here. And then 1, 2, 3, 4, 5. It goes to 1024. 1024, and this is 0. Well, I certainly should have put a negative sign here, or else your money should have exploded. Now you get 2 4096s. Good. Now again, 5 more years. You get to this point over here where you owe a lot of money. You owe this much money while you still don't have any real money. It's just like a superstar going the opposite way. They're already very zoomed out. Take away this and then try it again. It looks just as much as it was. Well, I guess we tumbled over again. This time on the opposite side, right? So these superstars 3 and 5, all those off, definitely. 7 is much more different from those. Well, 7 also produces a superstar like that. But what happens when we don't do? Hey, I put this whole thing in the wrong place. So better now. This isn't. Now I just have to copy the data. We'll just call it 3. And then at last we'll need 1, 0. Copying the data. Good. And then we'll do -4, -4. -4, -4. Sure, copy it. We could do it visually. 0, 32, 128, -128. 0, 32, 128, -128. Copy the same row again. Let's check what's on the bottom now. -1, 2, 0, 4, and 0. That's the next connection. And then we go up to 4096s. And then down to the final. Where there's a 0 again. But this time, oh. Uh-oh. Yeah, now we finally got it in the fold. The folds are so boring. So now it goes here. So we should add another table of what happens when you get two boards that you actually decide to skip 6. Okay, that's the spiral again. Let's go to default zoom. Change the color. Good. Now let's see what happens after the first 6 years. Wait, we didn't even have a start off. 6 years later, you'll be at this point. Six years later, at this point, 0 after next direction, and to count 6, I just crossed 3 4s. And the third 4 is exactly where the 6 is. Another 0, cross 3 4s to see that the next one is 5012. Another 3 zeros to see that the next one is 4096. Another 3 zeros to land precisely on here. And then it gives up on drawing the next 0. Let's compare it to the skip 2. Looks a lot less square. Default zoom. This crosses 3 corners of the square. Let's see what. Now, the S6 just is for skip 6. Good. Actually looks a lot less squarey now, but just zoom out to see that it actually is a much bigger squarey shape. Well, and now does look. Well, did we tumble over again? These pictures always make me think that I'm tumbling over. Hey, they meet at diamond shapes. That should be something to discover. Yes, they meet sometimes, but when they meet, they always meet diamond shapes. Because the shorter one goes 3 while the longer one only goes 1. At this point, another bank offers you a compound interest of I. And you say you take it. But they say, however, they compute interest every half year, so they only give you an interest of half I. Now let's see what happens. Well, we can still leave the crystal spiral. That's what I call a crystal spiral because it grows so quick like a crystal. And the other spiral grows so slow. But my computer totally gives up on drawing what happens after the 27/2 year, or the 13.5 year. It just gives me some two fractions added together. I added the first pair for the real money, but not the second pair for the imaginary money. So I just left the calculator, the sum, and then it just computed it. That one is a lot less happy. It grows so slow. It has to wake up and study, and I'll give you one moment to think about it. But over here, I will set up a 3-minute timer in a moment. Let's see where it is. So here I go. I'm setting the 3-minute timer. And now I'm gonna change the share to over here for you to think about it. So it is. So I'll leave you to study it for a moment. What do they have in common? And what does shortening the period do? I didn't have enough time to compare it with ones that compound even more recently, but I do have enough time to tell you that there is no more than 2 minutes left. Or what happens if you draw a spiral more slowly or quickly in the swimming pool with a stick? That's another quick think about, but now there's only 1 minute and a half. Now compare them. Now compare and contrast. There's no more than 1 minute now. And there are ripples in the water, like hyperbolic. And you might want to check out my video about the fourth dimension. So it actually isn't very hard to see the square if you only check every 6 years, and now there's no more than 15 seconds. 15, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and time's up. Okay, now I'm gonna switch a share. And I'm going to make launch. So it looks like that. It doesn't go very well with that. But I can make a better share with grids instead. I just have to wait for me. I'll make you a blank grid so that you can clearly see what I'm talking about. Good. I need a whiteboard. A gray whiteboard. Good. Now I'm going to share the gray whiteboard. Share. And now I'm gonna get what it looks like for this bigger spot. And then it totally goes out of the screen for the next one. And then it'll never come back again. So it does grow very fast. Meanwhile, on the other hand, the other spiral starts the same way, but then it just grows slower. Isn't a very good. This is what it looks with a grid. This is a grid. I have more freedom over here. I can make a unit more smaller over here if I want to. So it kind of looks like that. Wow, it's better if I fine. Show this. So now the difference is clear. One grows much more slower than the other one. And if you compound continuously, then you just walk in a circle. Your money never ever actually multiplies. You just walk straight in a circle like this. And then you keep walking in a circle. Nothing actually ever happens to your money. Well, but then, so it goes very interesting. So now it's probably time to back up into the imaginary bases. If you haven't, then you should probably see my video about base 2i, the quadrant imaginary base. Or I'll search it up. That's a triangle. Hey. Anyway, that's a triangle. I don't need this triangle over here. Instead, I'll search just quadrant imaginary base. The quadrant imaginary base. So that's some quadrant imaginary table. It looks pretty interesting over there. Anyway, I'm gonna search. Better complex base system. I'm gonna just base this. Good, that's the basis. Number basis. Good. Let's see what. So complex base 4.2. Better. List of numeral systems. So complex bases. Quite made that fun dragon base. That's better. So that's a little bit, but now we are going into the real curve. Actually, the real base. It actually, well, if you watch my 2i video, it shouldn't be very surprising that for all real numbers, you just stick another 0 bit in between because 1 plus I squared is 2i. And why did I say another? Because you have to go and watch the video. In the video, will tell you where the other one is. On the other hand, it is more better at describing complex numbers. For example, I is still the same, but just with zeros inserted between. But now 1.1 plus I instead is just 1 0. Good. It is more better at describing complexity. Good. It's a Negatwin dragon base actually. Good. So, but what about base 1 plus I over 2? That's okay. I'll add one more. I just have to decimal. So you can actually create your own activity over here. For example, I created the linear equations polygraph over here. These cars. And the last one, actually the last few ones, I can control their shape. Actually, let's go back. So I can create a new activity called other. Hey, why did I put a slash there? So and this time I'll add, it's better to just 2 represents space 2. Better to just do the line. So let's see that. Here, 0, 1, 1, 0, 1, 2, 1, 0, 3, 1, 0, 0. Not another 0. 1. So that's the example of binary growth. So it's better to see the binary growth if you actually put dots over here. You don't dot over here, another 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 dot over here, and finally one last dot goes over here. Good. So this is binary growth. Look, it's just stuff growing smaller and then big and then smaller and then bigger and then smaller and then big and then another big one. That one is the biggest and then small and then bigger and then small, biggest and then small and then big and then small. So actually, the growth pattern actually never So what's it about? So what is it with base 1 plus I? It's exactly like it's like the same thing. There's also a 1 plus I growth, but there's also a growth for every real number, but not for imaginary ones. There is, but it would be needed, but to describe it 3 dimensions, then we will need 3 instead of 2 for real number 3. 1 of those, and then 2 of those represent the complex plane. I scaled actually on the second page, I scaled the binary growth down so you can actually see how it works. But if I didn't scale it down, it should be way too big for you to see it. So I scaled it down by 100. So now maybe you decide that you should ask for more information if they're offering you an interest rate of 5. But take a quick look at what happens when we take a look at what happens when we instead switch from giving pleasure to base 2 to getting interest in base 3. So okay, it's first better if we maybe it's better to make a graphing calculator instead. We first start with the ordinary binary growth x2 instead of x. Lines and delete point. So this is a example of binary growth like this. This should be a 0. So this is exactly the same as what we had before. Zoom out. So this was a big growth. Zoom in. So this is actually 0, 1. We turn this into a 0. So this is binary growth. But I asked them to compare. So what do you think they should compare? Ternary growth. Good. Uh-oh. It is so slow. So it actually starts off at 0. Good. So instead we make it orange to compare. So it actually grows very slow, but sometimes there are just tiny bumps in it that happen every third time until it reaches this bump, which bumps it up over here. Then it continues its usually slow rise. So actually ternary growth is a much more slower process than binary one. The bump occurs at 9 and the big bump of the binary one occurs at 8. Okay, and it's better. So in 3 dimensions, the base 2i actually looks a lot like, or base 1 in 3 dimensions. It would be better with a 3D printer. But the other things are just good with 2D decimals. And there isn't a 3D decimal yet. But in case if you were interested, I could introduce quaternions at the end, which are actually the square roots of imaginary numbers, and they will take 4 dimensions to describe. Or they could also be described as 1 plus root 2 over root 2, or 1 over root 2 plus 1, or 1 plus root 2 could be simplified into root 2 over 2. So it's root 2 plus 2 over 2. It certainly is very strange with imaginary. And hyperbolic. Still no spiral appeared. Unless I stirred the water a little bit like this. Okay, and the compound interest spiral appeared, right? Didn't it? Or did you not see it? Then watch again. Compound interest spiral appeared. So this time you saw it, right? Did you? Yes, you did. So with the whiteboard over here. And this time magically I'm only sharing a bit of the screen. So yeah. Starts off like this. And then like this. This and then like this and then it just flies away. So that's what the spiral looked like to go back. Or to go back. So that's the times table again. Or again, that's the whiteboard. Or if you like it, then again, that's the imaginary interest. Hey, what did I do? It's better to just make a single. Take it over here so this is what the spiral looks like. Okay, toolbar. So that's what the 50 times 50 frame of the spiral looks like. That's the truth frame. Okay. So that's it for today. Well, I'll give you one more minute. Well, not there, but for the times table place, well, I do have a lot of things. That's the times table. And over here, I'm giving you a one. Hey, what just happened? Hey, where is the times table? Where is it? Anyway, I'll wait for the times table. Good. So white. It is better if you put white and good. Just white and white. And white and white. What do you guys think about taking the square root 4 times starting from base 16 if you like to think of it that way? And Wait. And wait. In a 1 minute time to look at this graph. Okay. Something is wrong with it. Good. So that's the spiral. So if you like to continue seeing the spiral, then I will put the link in the description. Have a good day.